Welcome to myprojectbazaar.com. Let us discuss our project. Our project title is Energy Balanced Unequal Layering Clustering in Underwater Acoustic Sensor Networks. Abstract. Underwater acoustic networking is the enabling technology for various applications. It is used extensively in activities such as underwater data collection and water pollution detection. It consists of a variable number of sensors that are used batteries as their power supply. This paper proposes an energy balanced unequal layering clustering algorithm that improves the energy efficiency of acoustic sensors. Also, this project aim is to prolonging the battery life of underwater acoustic sensor network by reducing their energy consumption. The main motto of this project is to improve their energy efficiency by reducing their energy consumption by using EULC algorithm in complex underwater environment. The process shows the effective simulation results by energy balanced unequal layering clustering, which balances their energy in USAN nodes and thereby prolonging the network lifetime long. Let us see the flow diagram of the project. First, system model. System model is based on the three-dimensional underwater acoustic sensor network structure, which consists of a sensor nodes and sync nodes as an base station. It is basically comprises a static sensor nodes affixed to the seabed, dynamic sensor nodes floating in the water, and zinc node floating on the surface of the water. During the USAN deployment phase, sensor nodes are randomly distributed within a cubic volume and the zinc node is placed on the water surface. The zinc node is located at the center of three-dimensional network's top surface and can communicate with all the nodes in the network, whereas sensor nodes also periodically collect the data. The algorithm used in this process is Leach, DEBCR, EULC. Leach and DEBCR is the existing system. Leach is nothing but low energy adaptive clustering hierarchy. This protocol adapts the method that selects the cluster heads at random manner, which avoids the cluster head to be premature death. Hence, compared with the general routing protocols, static routing protocols, Leach protocol can prolong the lifetime of wireless sensor networks. It did not consider the residual energy of nodes when selecting cluster heads, which may lead to the nodes with very low energy to be cluster heads and premature the death of clusters. The existing method of DEBCR is depth and energy based clustering routing algorithm. It is used in three-dimensional underwater environments in which the selection of cluster heads it is based upon depth and residual energy with their non-cluster head nodes by selecting their clusters. Also, on the differences between their depth and those of their respective cluster head nodes, resulting in a conical network structure. However, the DEBCR algorithm cannot guarantee the quantity and stability of cluster heads. That's why we use the EULC algorithm in proposed method. This energy balanced unequal layering clustering algorithm divides the underwater acoustic sensor network into the separate layers based on their depth and clusters within each layer. The algorithm selection of cluster heads takes each node's residual energy, node degree, and distance to the sync node into account, resulting in a more uniform distribution of cluster heads. It is mainly used to reduce their energy consumption in inter-cluster communication. Next, hope node is selected in accordance with their residual energy and depth. Also, It is based by the cluster head selection and energy consumption. The cluster head at the top layer sending data to the sink node. Layering can enable uniform distribution of cluster heads in USAN. It is simplifying the network model and helping the balance in energy consumption. To address the hotspot issue, the EULC model divides the network into layers with an equal layer spacing that gradually increases from top to bottom. After the following procedure in the system, the performance is evaluated by calculating the survival periods of the node. The result, which shows the decrease in number of surviving nodes as the number of turns increases. Also, it shows the time at which the first node and 30% of all nodes die for these three algorithms. Although the three algorithm energy balanced unequal layering clustering is successfully receives the most packets from cluster heads, indicating the ability of EULC to efficiently promote the network energy utilization. Now we are going to see the running procedure in MATLAB 2017 B version. Right click on source code and click run button. Now wait for a few minutes to receive the outputs. This is our first graph, which is system model. It is basically based on three-dimensional underwater acoustic sensor network structure. It consists of sensor node and zinc node as the base station. It comprises a static sensor nodes affixed to the sieved and dynamic sensor nodes floating in the water and zinc node floating on the surface of the water. Here we are taken zinc node is center of the three-dimensional network top surface, and it can be communicate with all the nodes in network, whereas sensor nodes periodically collected data and informations. This is our second graph, which is x-axis is an simulation time and y-axis denotes the number of cluster heads. Here EULC increases dynamically by taking a random generation of numbers, whereas leach and DEBC are taken as static variable. Next, this is our third graph, average energy consumption. Normally, electric energy consumption, it is the form by normal consumption that uses electric energy. It is the actual energy demand made on existing electricity supply and representing a constant power over a period of time. Here, EULC process, which calculates the average energy consumption per node over one turn, and residual energy as the number of simulation turn increases. This is average node residual energy graph. Here, unequal layering and clustering approaches effectively addresses the hotspot issue and balances the inter and intra-cluster data transmission energy consumption. This is our fifth graph, which denotes the number of surviving nodes. Here, each node calculates its distance to the sink node based on the received signal power and then estimates its layer based on their depth. This graph represents the number of packets received by the zinc node, which is here taken x-axis as an simulation time and y-axis is how many number of packets received in per one turn. This is our final graph, times at which the node and 30% of node dies. In the system, the performance is evaluated by calculate the survival periods of the node and the result, which shows the decrease in number of surviving nodes as the number of turn increases. Also, it shows the times at which the first node and 30% of all nodes die for leach, DEBCR and EULC. Although these three algorithms, EULC successfully receives the most packets from cluster heads, indicating the ability of EULC to efficiently promote network energy utilization. These are the discussions and results presented in this process. Thank you for watching.